Alexa, trigger forward. Our goal today is to build Alfred, a fully functional, voice-controlled servant robot that can walk and execute commands on demand. What makes this build highly accessible is that you can construct the entire system from start to finish with absolutely zero soldering. We are also going to solve a massive cybersecurity risk common in DIY robotics. We will establish remote voice control entirely without opening your router to the public internet through port forwarding. To make this happen, we need a few specific components: a Raspberry Pi, an Arduino, 8 SG90 servo motors, an acrylic chassis, and an HC06 Bluetooth module. By combining these specific off-the-shelf microcontrollers, we can safely bridge physical hardware to cloud computing without compromising your home network. We start with the physical preparation of the chassis. You'll need to peel back the protective paper layer covering all of the clear acrylic parts before assembly. To move this chassis, we use SG90 servo motors. Unlike standard motors that spin continuously, servos are precise positioners designed to move to and hold a specific angle. We mount 8 of these servos symmetrically across the base to mimic a biological leg, dedicating individual motors to the hip, knee, ankle, and foot rotation joints. When these 8 servos operate together to carry the robot's weight, they generate intense physical vibrations. Left alone, those vibrations will quickly loosen the hardware and cause the robot to shake itself apart. Instead of buying specialized chemical thread lockers, you can secure the entire chassis by applying a simple dab of hot glue to every tightened nut. This ensures the hardware stays locked under heavy vibration. With the chassis secured, we wire the servos into the Arduino microcontroller and upload the core leg algorithm to the board. Inside the algorithm, the move joint function tells a single servo exactly which angle to hold. Looping dozens of these adjustments together instructs the robot to lift a leg, shift weight, and maintain balance. This is how the system executes complex sequences like walking forward. Before you power the board, check the orientation of the HC06 Bluetooth module. Inserting this specific component backward will permanently fry it. Translating these simple text-based angle parameters into continuous physical balance is exactly how we generate realistic robotic locomotion. Now we set up the brain of the robot. We install the Alexa AVS sample app onto the Raspberry Pi to handle our voice processing. To link the Pi to the Arduino, we open the Linux terminal, run the Bluetooth CTL pairing sequence, and manually trust the HC06 module's MAC address. Normally, remote IoT control requires opening a router port, punching a hole in your firewall that gives the public internet access to your local devices. We bypass this risk entirely, using if this then that to safely link Alexa to a dedicated Gmail account. In the IFTTT interface, we set the trigger phrase to forward. When Alexa hears this, IFTTT sends an email to our dedicated account with the subject Alfred and a message containing the single letter F. Meanwhile, a Python script running on the Raspberry Pi constantly pulls that specific inbox. When it detects the email, it reads the letter F and instantly transmits it over Bluetooth to the Arduino. Because the Pi is only reaching outward to check an email, no inbound router connections are required. This asynchronous email bridge acts as a virtual air gap, granting you global voice control while keeping your local network completely invisible to external attackers. Run the Python script on your Pi, make sure Alexa is listening, and issue the command: Alexa, trigger forward. A few seconds later, the joints move into perfect synchronization, and the completed robot walks across the desk. That physical movement is the result of a data package that travels from your voice to Alexa, out to IFTTT and Gmail, back down to the Pi, over Bluetooth to the Arduino, and finally into the servos. Now that you have a working base, you can open the Arduino code and modify the move foot and joint angles to program custom walking animations or dances. By mastering this secure approach to combining microcontrollers and cloud computing, you now have the foundational architecture to build and control any internet-connected system safely.